Hello, I'm Mr. McBrien. This is tej3m, the binary number system. The Ontario curriculum states that students will demonstrate an understanding of the use of binary numbers, hexadecimal numbers, and Boolean logic. Today we're going to focus on the binary number system. So first, a quick reminder about the decimal system. Some of you are familiar with it. We have our base 10 system that we have used with our 10 digits representing, of course, our 10 fingers. We have in that system available to us our 10 digits, and with the use of zeros as placeholders, we can actually, of course, designate much larger numbers. And each one of our digits then represents 10 to the exponent of something. So our first digit, 10 to the 0, gives us our 1s. 10 to the 1 gives us our 10s. 10 to the 2 gives us our hundreds. And sorry about that. And so we can represent larger numbers than 10 by simply adding those together. No great shock, most of you are familiar with this. The problem is that computers are limited to only 2 digits. Transistors can be, at least nowadays, can be only on or off. And so computers only get to play with 2 digits, and we had to invent a base 2 system, or arguably the computers invented a base 2 system for counting. But the basic principles are the same. The digits represent 2 to the 0, 2 to the 1, 2 to the 2, etc. And when we examine the number, of course, we're restricted to zeros and ones, but we can use the exact same principles to look at these numbers. Our first digit is 2 to the 0 or 1s. Our second is 2 to the 1 or 2s. Our third is 2 to the 2 or 4s. And our fourth is 2 to the 3 or 8s. And so 1011 can be easily converted to, in our way of talking, to being 11. And we can extend that principle out to larger numbers. If we want to do a conversion, one easy way to make sure we don't make any mistakes is just to create a little table and use this table each time. So in this case, I've prepared the first first 8 digits, meaning that on the left-hand side, I can represent my 128s. So our steps: draw the table, and then write the digits into the table. Of course, maintaining all of the zeros involved. And then once we do this, we have a simple addition problem. We move up to the top, we scratch out the ones that have zeros, we move up to the top and add together, in this case, 1 plus 4 plus 8 plus 32, by my count, about 45. So trying another one, exact same process. We can write in a 0, a 1, 0, 0, and 1. 32 plus 4 plus 2. You can do these on your own. Okay, decimal to binary is not quite as simple, but the same ideas work. We just have to do it in reverse. So if we take 15, for example, we can start from our table and by examination see that 128, 64, 32, and 16 are all too large, and we won't be using them. And so we can write in zeros if we want to, or just ignore them. Then when we reach 8, we can observe that 8 is in fact smaller than 15. Write in a 1, and then subtract 8 from the number, and we're left with 7. We move down to the 4s. 4 is smaller than 7. We can write in a 1, subtract 4, giving us 3, and so on. So this is really a process of examination and then subtraction. Okay, so trying another one. If we have the number 75, we can see that 128 is too large, 64 is smaller, so we write in a 1 for 64, subtract 64 from 75, getting by my count 11, which means the 32s and the 16s are irrelevant. We write in zeros. For the 8, we write in a 1. Subtract 8 from 11 gives us 3. 3 is smaller than 4, write in a 0, and so on. So a quick reminder about adding decimal numbers. When we add decimal numbers, it's pretty trivial really, except where we get to carry over. So we add together, in this case, 16 plus 25. 6 plus 5 is 11. We write in the 1 and carry the 1 to the next digit. And then we add together the 1, and the 2 to get the 4. And of course, this is a review of something you've known for a long time. There's really no difference when adding binary numbers. So we only have to remember that we mustn't write in 2s, 3s, etc. We can use precisely the same logic, just carrying a digit whenever we get to the number 2. So let's do an example. 101 plus 11. When we look at this, 1 plus 1 is 2. We can't write in a 2, so we write in a 0, move the 1 to the other side, and now we have 1 plus 0 plus 1, which gives us another 2. We write in a 0, carry the 1 again, and notice we've got another 2. So the answer to 101 plus 11 is in fact 1000. We could do a lot more arithmetic. We can do division, multiplication, etc. We're going to define this as outside the scope of tej3m for time purposes, but also we don't need to turn ourselves into computers. So for your homework, please go through the worksheet, do the conversion to and from binary, and the addition of binary numbers. You can wait to see the answer key, or you can find quite easily online calculators to check your answers. Thank you.